Hello everyone, hope you all are doing well and enjoying coding. My name is Vishal Barot and today we are going to discuss about Python variables in this video. So let's start with the Python variable. So the first thing that comes in our mind is what is variable. So variable is nothing but a container which can hold a value, and that value can be accessed by a name, that is nothing but a variable. If I say that I would like to store a particular number and then I would like to access that number for further operations. For an instance, let's consider that I have written a is equal to 15, which means what? I would like to store this 15 value into this variable a. Now, in many programming languages like C, C++ or Java, we need to declare the variable first. Then and then you are able to access that variable. But in Python, this is not the case. In Python, you can use the variable as and when needed, which means here I have not made any kind of declaration of the variable. I have simply written a is equal to 50. Is equal to is nothing but an assignment operator, which means we are trying to assign the value 15 to the variable a. A is our name of the variable. When you write a is equal to 15, how interpreter or compiler works based on the particular language that you are using. If we talk about Python, so in Python, when a is equal to 15, that particular statement will be executed. At that time, Python interpreter allocates some memory and stores the value, and that particular memory address will be accessed by a particular variable. In a simple term, if I say, so that Python interpreter allocates some memory and stores the value in the memory space, and then that particular variable will be referenced to that particular memory address. For an instance, if I take another variable, that is b, and b is equal to 20. Again, if I try to execute the code, Python interpreter allocates some memory and stores the value 20 in a memory space. Here we have considered the address 2000 and 4658 for a and b respectively. That address will be generated dynamically. B is equal to 20, which means the value is 20 and the address is 4658. And in other words, I can say that B is referencing to the address 4658, which means whenever you would like to perform any operation with A or B, for an example, if I would like to perform the operation A plus B, A minus B, A plus 10, at that time by using that A, we are able to access the value 15, which is stored at address 2000. In the case of B, the value which is 20, it is stored at the address 4658. This is how the interpreter works. It first assigns the memory address, and that memory address store a particular value, and B is nothing but a reference to that particular memory address. If I say that in many programming languages like C, C++ and Java, as we had discussed, that particular programming language has a scenario different. And if we talk about Python, there is one important thing that we need to understand, that how the memory will be allocated during the execution. So let's discuss the scenario of other programming languages first. A is equal to 15, B is equal to 15. Now the value of both the variable is same, which is 15. When I try to execute the statement in a particular language, it depends on the compiler or interpreter of the particular language. It assigns that value, it allocates a separate memory for both the variables and store that value in that particular memory address, and that particular variable would be referencing to that memory addresses. Now, this is not the case in Python. If we talk about Python, in Python the memory allocation is being done based on the value. So if I say I do have the value a is equal to 15, I would like to store the 15 value into a, which means what? It first try to find whether this 15 value exists in my memory or not. If it is there, then the scenario would be different. But let's assume there is no value, there is no memory allocated for 15 value, which means it will create a separate memory slot, store the value 15, and now a references to that particular address. In our example, we have taken 2000 address. That memory address is 2000 and a references to 2000. Now I would like to assign the another value which is 15 to b. Now the value is same. Now here what a Python interpreter does, it tries to check that whether this 15 value is already available in a memory or not. If it is already available, it does not create another memory slot. It only reference to the same memory address which has been already allocated to a different reference, which means we can say that A and B both are referencing to the same memory address now. So by using A or B, if you are trying to access A or try to access B, you can access the same value which is 50. Let's understand this using some different scenario. In Python, many of the material says that there is no variable concept in Python. There are only tags are available. So let's understand according to. When I say A is equal to 15, that I would like to execute this particular statement. A is equal to 15, as I said, it first checks in the memory slot whether the 15 value is available or not. If it is not available, it creates a kind of pillar. And that pillar would be stored in the memory slot of particular address, and particular variable would be tagged, as you can see on the screen. That particular variable would be tagged to that pillar. Now I'm going to assign a new value. I'm going to declare a new variable which is B, and the value of B is again 15. So what happens here, that interpreter tries to check whether this 15 value already exists in memory or not. If it is exists, which means what, it does not create another memory slot for the variable B. It only tagged that B variable to the same memory address. So now I can say that in a particular memory address which is 2000, there are two tags A and B, which means A and B are referencing to 2000. Now if I execute the another statement which is A is equal to 55, here we can override the value, like in normal programming languages we can override the value. The same way Python supports the reassignment of the variable. So if I write A is equal to 55, which means I am trying to modify the value of A, and that is what the meaning of variable, that can hold something and it can vary during the further execution of your program. So now I am going to execute A is equal to 55. So what happens? It tries to find in the memory slot whether 55 exists in memory or not. If not, it has to create another pillar, another memory slot and store 55 value. If 55 is already exists, then A would be tagged on that particular memory address. But in our example, we had only taken the 15 value. So another pillar would be created, which is something else, some other memory address, which is 4800. That is again the example. Now that A variable would be tagged on that particular memory address which is 4800. But what about the memory address 2000? A would be unlinked from that 2000 memory address, and A would be now linked to the new memory address which is 4800. So we can say that now A references to 4800 memory address. This is what the tag which is reallocated to a different memory address. Now going further, if I say that the value of B I would like to change, and the value of B is again 55. So again Python interpreter finds that 55 is already exists in my database or in my memory, not in database, in my memory slot. So in my memory slot, if 55 exists, at that time I am not going to create another pillar or another memory slot in my memory. So at that time again B would be tagged onto the same memory address which is 4800. So now again A and B are nothing but the references to the memory address which is 4800. But here, what about the memory address 2000? What about this? So here the role of garbage collector comes. If you do not understand garbage collector as of now, do not worry about it. But let me tell you a very simple definition of it. Whenever a particular place in the memory is not being used by the interpreter, at that time garbage collector will release that particular memory. So how that particular memory will be released? Based on what? It based on the reference count. So now what is reference count? A reference count is what? The number of times that particular memory slot is being referenced. In this case of 4800, I can say that the reference count of 4800 is 2. In the case of 2000, I can say that reference count would be 0 of 2000. So whenever the reference count of a particular memory address becomes 0, at that time garbage collector will release that particular memory. And the use of garbage collector is what? When it releases the memory, that particular memory slot can be used further. And that is what the meaning of garbage collector is. So again, I'm saying, if you do not understand garbage collector, do not worry about it. In this video, we are not going in detail about the garbage collector. We are only trying to cover the concept of variable and how it works in Python.